For decades, cryptographers and computer scientists were chasing this singular, seemingly impossible goal: creating functional, purely digital cash. Now, the main hurdle wasn't actually writing the code. No, the real bottleneck was something called the double spend problem. Think about it for a second. Digital money is essentially just data, right? And as we all know, data, like an MP3 file or a JPEG, can just be copied and pasted into infinity. So without a central bank or some massive credit card company acting as a referee to check the ledger, how do you mathematically prevent someone from spending the exact same digital dollar twice? Well, that was basically the holy grail of cryptography. And solving that massive mechanical puzzle, creating a system that operates completely trustlessly without any central authority, is the absolute monumental triumph that Bitcoin's architecture finally achieved.
So how does Bitcoin actually work? Okay, let's really dive into this. To understand what's happening under the hood, we have to look at why it succeeded where previous attempts at digital currency, stuff like e-gold or hashcash, ultimately stalled out or just completely failed. When the famous Bitcoin white paper dropped back in 2008, it proposed a brilliant solution to what computer scientists called a Byzantine generals problem. Basically, in a decentralized network where anyone can join and anyone can leave at any time, how do thousands of complete strangers agree on a single, indisputable truth without a central leader telling them what that truth is? Well, Bitcoin solved this by perfectly aligning game theory with cryptography. It actually ensures that it's always overwhelmingly more profitable for participants to play by the rules and validate the truth rather than trying to attack or cheat the system.
And the foundation that makes all this decentralized consensus possible is the blockchain, the powerful decentralized technology that runs the Bitcoin network without any government or bank control. Now, we constantly hear blockchain thrown around as a corporate buzzword, but mechanically, it is an absolute masterpiece of software engineering. It's an immutable, decentralized ledger maintained by a globally distributed network of nodes. Instead of one single bank holding the master copy of a ledger on a private, locked-down server, you've got tens of thousands of independent computers all around the world maintaining the exact same constantly updating record. Think about that. There's no CEO you can subpoena, there's no headquarters to shut down, and there's absolutely no single point of failure. It's a network that survives and operates strictly on mathematical consensus.
A really common analogy is to think of the blockchain as a shared digital notebook. But it is super important to understand just how incredibly secure this particular notebook really is. Every single time a page, or what we call a block, is filled with transactions, it gets cryptographically sealed to the page that came immediately before it using these complex hash functions. And that right there creates an unbreakable chain. If a malicious actor wanted to, say, secretly alter a transaction from 3 years ago, they couldn't just grab an eraser. The cryptography ensures that changing even a single comma in a past block completely scrambles the math for every single block built on top of it. The entire network would instantly look at that, recognize the data as invalid, and completely reject it. It makes altering historical transactions practically impossible. So let's actually walk through how these mechanics handle a real-world action. Step 1. You open your crypto wallet. But here's the thing, you aren't actually sending a file. You're signing a cryptographic message with your private key. Step 2. You broadcast that transaction into what's called the mempool, which is basically a waiting room for unconfirmed transactions. Step 3. Thousands of computers instantly verify your ownership. They check your digital signature against the entire history of the blockchain to make sure you actually have the funds to cover the transfer. Step 4. Specialized computers pull your transaction from that waiting room and add it to a new block. And finally, Step 5. The network agrees on the block, the transfer is permanently finalized, and the Bitcoin is received. No clearinghouses, no 3-day bank settlement periods, just pure, peer-to-peer code executing the transfer in minutes.
Now, those specialized computers we just mentioned that bundle the transactions, those are the miners. And this brings us to a huge misconception. The myth is that people are virtually digging for gold, swinging digital pickaxes looking for hidden coins. But the reality? It's just computers solving incredibly complex math problems. It's driven by a consensus mechanism called proof of work. Miners are deploying massive arrays of specialized hardware, all running the SHA-256 algorithm. They're basically engaged in a global brute force guessing game, racing to find a highly specific alphanumeric string that validates the next block. Just to put this into perspective for you, the total computing power dedicated to this network right now is vastly more powerful than the top 500 supercomputers on Earth combined.
And that staggering amount of computational energy is definitely not wasted. It's exactly what provides an impenetrable wall of network security. In exchange for spending massive amounts of electricity to secure the chain, the winning miner gets a block reward, newly minted Bitcoin, plus all the transaction fees from that block. But here is the truly fascinating mechanical twist that drives all of Bitcoin's economics: the halving. Hard-coded right into the protocol is a rule that every 210,000 blocks, which takes roughly 4 years, the amount of new Bitcoin rewarded to miners is automatically slashed perfectly in half. This brilliant little piece of code ensures that the inflation rate of Bitcoin steadily and predictably drops over time. Which leads us to the ultimate number, 21 million. Because of that halving process, there is a hard, unchangeable cap. There will never, ever be more than 21 million Bitcoin. And it's really crucial to understand how this is enforced. It isn't a suggestion, it is a consensus rule upheld by the network. If a miner successfully mines a block but tries to get sneaky and write code paying themselves, say, 50 Bitcoin instead of the current valid reward, the thousands of nodes around the world will instantly look at the math, flag that block as invalid, and throw it out. To actually change that 21 million cap, you would literally have to convince tens of thousands of fiercely independent node operators worldwide to willingly dilute their own purchasing power, which, let's be honest, is practically unimaginable.
That unbreakable cap introduces a concept we rarely ever see in economics: absolute scarcity. Think about physical gold for a second. If the price of gold skyrockets, mining companies suddenly have the budget to buy better equipment, dig deeper, and flood the market with a larger supply of gold. But Bitcoin's supply schedule is completely inelastic to demand. If the price spikes and a million new mining rigs suddenly turn on to chase the reward, the network just automatically adjusts the difficulty of the cryptographic math problem upward. It basically makes the game harder, ensuring a new block is only found every 10 minutes, no matter how much computing power is thrown at it. That inelastic, mathematically guaranteed scarcity is exactly why it earned its famous nickname, digital gold.
Now we have to talk about the flip side of this. While the cryptographic math governing the blockchain is incredibly secure, the human element using it is highly vulnerable. Because Bitcoin completely removes the bank, it also completely removes your safety net. You've got security risks like scams, fake investment schemes, and stolen passwords. There's this legendary story of James Howells, an IT worker who accidentally threw away an old hard drive that held the private keys to 8,000 Bitcoins. To this day, he's actively trying to get permission to excavate a city landfill in Wales to find it. Why? Because in a decentralized system, there's no 1-800 customer service number to call. There's no forgot my password button. The core rules are absolute. Use trusted platforms and never ever share your private keys. Self-custody means ultimate responsibility.
But when you step back and really look at the gears turning inside this machine, it's a completely new way to send and store value. The elegance of this system is just undeniable. It combines decentralized ledgers, proof-of-work consensus, and an inelastic supply schedule into this totally self-sustaining economic engine. It's not magic, right? It's just a meticulously engineered protocol. And the machine just keeps ticking, producing a new block every 10 minutes. It's fully transparent, utterly secure, and completely indifferent to global politics or what the central banks are doing. This application of cryptography has fundamentally proven that value can be sent, stored, and secured globally without relying on a single middleman.
So, after all that, would you invest in Bitcoin? Now that you understand the actual mechanics operating under the hood, the cryptography, the game theory, and that absolute mathematical scarcity, where do you land on its future? Do you view Bitcoin as just a highly volatile, speculative asset, or do you see its decentralized architecture as the inevitable foundation of a completely new global financial system? If this breakdown helped clarify the intricate mechanics of the network for you today, please hit that like button, subscribe for more deep dives into crypto, AI, and technology, and jump into the comments right now to let me know your thoughts on Bitcoin's long-term trajectory. Thanks so much for learning with me today, and I'll catch you in the next explainer.